All right, we have a quick integral today. This one's from Caltech Math Meet 2024. And on this one, the first thing I was tempted by was because we have x to the fourth here. This thing's a fourth root, so I wanted to do the u substitution for x to the fourth. I don't know though, because it just doesn't work that well with 2x. I mean, I'm sure you probably could make it work, but I didn't go that way. Instead, I just wanted to use that 2x, because you'll notice if instead of substituting for x to the fourth, if I make my substitution for x squared, then du is going to be 2x dx, which is exactly that numerator. So when we do this, we can't clean that all the way up to a half, but if you put it in here and you square it, it just becomes square root of 1/2. Or you could also write this as, 1 over square root of 2. You plug a 0 in, it's just 0. All this numerator stuff is du, and this is going to transform to 1 minus u squared. But this integral right here, this is exactly in the form for arcsine. So if we integrate that, this thing becomes just arcsine of u evaluated from 0 to 1 over square root of 2. Plug in arcsine of 1 over square root of 2, that's like sine at pi over 4, 45 degrees. So this is going to be pi over 4. Arcsine at 0, that's just 0. Put it all together, and for my solution on it, we just get pi over 4, and that's it. Let's do one more because I have another quick integral, and I don't know, I don't really like making a 1-minute video. That was going to be like a 1-minute video, I think. So let's do like a 2-minute video, or let's do a 3-minute video with this next easy one. We'll look at problem number 7. Okay, the nice thing about this one is this is the kind of problem where you might not need paper. It's kind of really just recognizing what's going on. Now the giveaway on this one is just the bounds. Whenever you have bounds symmetric around 0 like this, one of the first things I like to think about is either odd or even functions. Now here it's a little more complicated because we're mixing things. A constant is always an even function. X squared is an even function, so the whole denominator is an even function. But sine is odd. So the only trouble we have is we're kind of mixing odd and even, but we have it broken up on a plus sign, so we can just split this up into 2 integrals, and then it's going to become really pretty simple, I think. So let's do that. And just by splitting it up, I think we're kind of all set, or we're going in the right direction anyway. The reason is because this thing here is actually an odd function. Actually, I should just say this right here, or this right here is the odd function. If this is our f of x, the quick check you can do in your head is just think about f of minus x. When you plug f of minus x in here, and the denominator goes away when you square it, but there's still a minus here. That'll turn into sine minus 2x, but then the minus sign can come out front. And so what you end up with, this whole thing here, if you plug in minus x, is the same thing as minus f of x, which is actually the test for an odd function. And for an integral of an odd function with symmetric bounds, this always goes to 0. So this whole part just goes away, and then we just deal with this. This one, I mean, you actually don't really need the check on even functions, doesn't help that much, but we'll do it anyway. Again, everything's even. It doesn't matter that it doesn't need to be 4. This could be like a 3. A constant is always even. Even exponent is even. When we have an even function with symmetric bounds, we can make this a 0 and pull a 2 up front. But then this thing can be integrated really quick with the arctan formula. 4 is just a constant, so when we do this, multiply that out, we have an 8 in front, integrate this with the arctan formula, and what we get is arctan of x. Think of this as 2 squared, so we end up with a 2 in the denominator here, and actually it also comes in front here, so we should have like a 1/2 over here. And we just need to evaluate this from 0 to 2. Again, this thing is going to be a 4 in front. So simplifying it, we end up with 4. This becomes arctan of 1 minus, plug in a 0, and we have, this is just arctan of 0, but that's just a 0. Arctan at 1 is pi over 4. Distributing the 4, and for my final solution on it, we just get pi, and that's it. You know what I just realized? If instead of having a 4 here, if that was just a 1, then we could have got the same solution, right? If we put this back as a 1, then we come down here and this becomes pi over 4. We would have had the same answer for both of them. Too bad. But that's not quite what it was, so let's get rid of that. But anyway, there you go. 2 quick integrals. That's all I have for today. Thanks everyone for watching. Have a good day.